This video is going to be on how to convert a quadratic into vertex form. So converting. So our method for doing so is called completing the square. And this method should not be new to you. You should have done completing the square as a method of solving a quadratic. And this year in Math 3, we don't really do that as much. We'll say that when you solve a quadratic, you can factor or use the quadratic formula. But completing the square is really important for turning a quadratic into the vertex form. And it's something that you'll continue to do throughout math. Not all the time, but it happens every so often, especially later on when you learn about circles. So first, we're just going to go through some background information of this. So examples of squares would be something like x minus 1 squared. So that's the same thing as x minus 1 times x minus 1. So this is going to be kind of the goal of the video, is to make our equation look like this. But if we look at what we had to start with, we would see what this is when you FOIL it. So that's x squared minus x plus 1. So x squared minus 2x plus 1 would have been the form we started with. And then when we complete the square, we would have it look like this, and then it would be in vertex form, and you could find the vertex and see the transformations and all of that. Another example is x plus 3 squared. So that would be x plus 3 times x plus 3. And if we FOIL that, we get x squared plus 3x plus another 3x plus 9. So when we talk about squares, what I mean by that is that a square is a binomial factor. This is binomial, it's 2. It's a binomial factor multiplied by itself. So squares are a binomial factor multiplied by itself. All right, so if I was to complete the square for a problem like x squared plus 8x plus something, I would want to figure out what goes right here. And then I would want to figure out how I could write it as a square. So if you notice, if we kind of work this process backwards, then the middle term gets split in half. So I'm going to think of this as x squared plus 4x plus 4x plus something. And then if you notice, the way that we got this number on the end, we had 2 3's, right? That's how we got 3x and 3x. So here, if we got 4x and 4x, then that would mean that like this, we had 3 times 3 is 9. We would have 4 times 4 is 16. And then if we backtrack a little further, that tells us that this would have been x plus 4 times x plus 4. That's what they would have FOILed to get to that. So we would have had x squared, x times 4, 4 times x, and 4 times 4. And so written as a perfect square, this is x plus 4 squared. So we complete the square by adding 16, and we would say the completed square is x plus 4 squared. Okay, so I'm going to write this in my notes, complete the square by adding 16. The completed square is x plus 4 squared. Okay, so we're going to go ahead and walk ourselves through some problems where our goal is to complete the square. All right, so I'm going to say complete the square. All right, so for the first example, I have x squared plus 10x plus something. So just like we did up here, we're going to think about taking that middle number and dividing it in half. So 10 divided by 2 is 5. And then after we divide that number in half, we're going to multiply it by itself because we know that this was x plus 4. And when we multiplied 4 times 4, that's where we got the 16. So divide it in half, that's 5 and 5. And 5 times 5 is 25. So to complete the square, I would add 25. And then if I write this in completed square form, that would be x plus 5 squared. All right, example 2. If I have x squared minus 12x plus something, I'm going to do negative 12 divided by 2, and that gives me negative 6. And then I'm going to multiply negative 6 by itself. That gives me 36. And then if I write it in completed square form, that would be x minus 6 squared. If I do x squared minus 100x plus something, I'm going to go ahead and start by doing negative 100 divided by 2, and that gives me negative 50. And then I'm going to do negative 50 multiplied by itself is 2,500. So 2,500 completes the square. The completed square form would be x minus 50 squared. We can even do this with odd numbers. So example 4, if I had x squared plus 9x plus something, then I would say 9 divided by 2. I'm going to leave it like that. I'm not going to do decimals. So I'm going to say 9 divided by 2 is just 9 halves. If I multiply this by itself, then the number that completes the square is 81 fourths. And then if I write it as a square, that would be x plus 9 halves squared. Right? So we can do this with a lot of different problems. We just take the middle term, we divide it by 2, and then we square it. And you'll notice that whatever you got when you divided by 2, that's what ended up in that square form. So positive 5, this one was negative 6, this one was negative 50, this one was 9 halves. All right, so now we're going to go ahead and take some quadratics that are in standard form, and we're going to convert them into vertex form. All right, so convert into vertex form. And the process we're going to use for that is completing the square. We are on example 5. So our first problem says y equals x squared plus 6x plus 3. So the first thing I want to do is I want to make it look like those other examples where I have like a blank that I'm filling in. So the first thing I'm going to do is I'm going to minus the 3 over to the other side. So I've got x squared plus 6x plus something. Then I can do the part where I divide by 2. So 6 divided by 2 is 3. 3 squared is 9. So I can add 9 to complete the square. Now I have an equation this time. So if I want to keep the equation balanced, when I add 9 to the right side, I also have to add 9 to the left side. So now I have y plus 6 equals, and I can take this, now that the square has been completed, and I can write it in the completed form. So that would be x plus 3 squared. And then I can go ahead and take the 6 and move it back over. So my vertex form is y equals x plus 3 squared minus 6. If you want to check your problem to see if you did it correctly, you can go ahead in your calculator and you can graph this parabola right here and graph this parabola at the same time. And when you look at the graph, there should only be one because they're equivalent forms. They just look different, but they should give you the same picture. All right, example 6. So this one is going to be y equals x squared minus 8x plus 7. So just like before, we're going to take the number on the end and we're going to move it over so we can have that blank. So I have y minus 7 equals x squared minus 8x plus blank. And then I can go ahead and say negative 8 divided by 2 is negative 4. And negative 4 squared is positive 16. So since I added 16 to the right side, I need to add 16 to the left side. And so on the left side, that gives me y plus 9. And on the right side, if I write it in the square form, then that's going to give me x minus 4 squared. So I can go ahead and minus the 9 back over. And I have it in vertex form. So now I can easily see, oh, the vertex is positive 4 and negative 9. Or I could easily answer a question about the transformations, or I could easily answer a question about increasing and decreasing or domain and range. All of those questions are a little bit harder to answer when it's in that original standard form. All right, last example, I wanted to do one of the odd numbers divided in half. So for this one, we're going to say y equals x squared plus 5x minus 2. So I'm going to start the same way. I'm going to move the 2 over so I can make my blank. And then I'm going to go ahead and take the middle term and divide it by 2. But this time I'm going to leave it as a fraction. So I've got 5 over 2. When I square that, that's going to give me 25 over 4. 25 over 4. All right, so since I added 25 over 4 to the right side, I have to add 25 over 4 to the left side. And so that gives me, I have 2 plus 25 over 4. If I want to write 2 as a fraction, and I want that fraction to be over 4, then I'm going to say something over 4 plus 25 over 4. And I know that this fraction needs to equal 2, so it must have been 8 over 4. So I've got 2 plus 25 fourths, and that gives me 33 fourths. And then I can go ahead and write my squared form. So I have x plus 5 halves squared. And then I'll go ahead and minus that 33 fourths over. So y equals x plus 5 halves squared minus 33 fourths.